So when we're going back and either looking at our quiz or looking at the factoring help sheet, which again I'll talk about here in just a second, when you're doing these, is there anything in common to factor out? Let me add something to that. Okay. Out of all terms. Okay. Like for instance on the example, I can take a 5 out of each of those. So I went ahead and did that. But let's say you have something like, I don't know, 3x squared plus 6x minus 7 or something like that. Now again, I know I can take a 3 out of those first two. I can divide them each by 3, but I can't do it for 7. So this one I'd have to slide and divide or whatever other method I'm using. To be able to take something out, it's got to come out of all of them. Okay? That was one of the dilemmas we sort of saw. The biggest one though, and it surprised me a little bit, was when we got down to the two-termers, the shorties, ones that look like this. That two-termer is supposed to be a really big clue to you. It's like, oh, they're perfect squares. Now, this comes back to, again, are we working on knowing our perfect squares? Because if you see any of these numbers sometime when you're factoring, that should automatically be popping into your head, ooh, perfect square. Okay, so this is 3 and this is 7. And some of you, even on a problem like this, got this far, but then you just did that squared. Again, it's foiling back through it in your head and thinking about it. If this were this squared, if I just said it was 3x minus 7, 3x minus 7, if you think about it for a minute, negative times negative would make it a plus 49. Well, that's not going to work already. So, okay, that doesn't make sense. It's about learning about number sense, what actually makes sense and what doesn't. Sometimes you may only be able to take a number out. That happens occasionally. But I think the biggest thing I noticed, most of you were good when you just had a diamond. That seemed to work okay. When it came to slide and divide, though, and I'm actually going to do this one right on here because I've just got the answer right now. And I think when we did this, we actually worked through it, but I'll work through it on here now. When you're going to do slide and divide, and some of you had parts of this, so you got partial credit. I may have written you a little note. Most of you were fine in getting to this slide part. And again, we just multiply the 20 down. And then most of you were even okay here to do your diamond, and you were like, okay, so x plus 15 minus 4. Okay, I'm okay here. But then you'd stop. And I'm like, okay. And we've always said about how if you FOIL out your answer, you get the original problem back. Well, I'd see that problem right away here. X times x is x squared. It's not 3x squared. Wait a minute. There must be something else I need to do. That's the type of thought process because some of you did the slide part, but you didn't do the divide. So once you divide, you have to reduce your fractions, and I wrote that on some of your papers, because if you forget, and I just swing this 3 back to the front, and I'll talk about why I would know that that is a bad idea here in a minute. 4 over 3, I can't reduce it anymore. And I can get to the answer. But here's what I found a lot of you doing. The issue I saw was that some of you would have that first one, the 3x minus 4, but then you'd also just automatically slide the other one right back, and this would be your answer. But again, we've got to think about it for a minute. 3 times 3 is 9x squared. Well, that's not 9x squared, that's 3x squared. Oh, wait a minute, I didn't reduce this fraction. Because if you FOILed this out, this comes nothing near to being this. So again, it's got to take that second and not just go, okay, I got an answer, I'm moving on. Look at it for a second just to figure it out. And that's why, specifically for this reason, again, when you're doing the factoring help, I don't want you to just be looking at the answers down at the bottom, matching up and saying I'm good. I literally either want to see your slide and divide steps, or when you get to an answer, I want you to FOIL it out so you make sure it's actually the right answer, because then it's going to be easy points on this homework check and not getting hammered for 9 points because you're still missing steps. And if you start trying these and you're not getting matches up, again, come and talk to me. We can try to work through some of this, or go back and look at the factoring video. If you're on my website or my YouTube and you just type in factoring up at the top, that'll get you to the right thing. It'll get you to the lesson. Okay? But do some of those things. Be proactive in trying to help yourself out somewhat. Okay? Any questions on the expectations of the factoring assignment, how it's worked, and when it's due, or any of that? Because I want to make sure we're on the same page with this. The thing that you just picked up today. Yeah, the one that's got the puzzle on the bottom. This, yeah, if you missed more than one question on the quiz in the first 6, it is a 9-point assignment in your next homework check next week. So you got a week. But again, like it says at the top, and telling me later, oh, I didn't see, no, I'm verbalizing it and it's written here. You show me your slide and divide steps on how you got to the answer, or if you did it in your head, you're going to use FOIL, you're going to FOIL it out and show me it gets you back to the original expression. You've got to show me this. We've got to be able to do this. And again, if you're going to come in and do the quiz retake, I want to see that you've gone back through some of this and tried to fix some things. You just come back in with, I'm going to give you the same shoulder shrug. We've got to work at this. And then if you're doing something, you're like, I'm still not getting the right answer. Okay, we'll fix it. But that's what we're up against here, okay? All right, now, to today for the time being. Graphing square roots. Now, I would suggest, and if you haven't, I should have said this at the beginning, but you can get it now. If you haven't, grab one of the calculators. You don't have to have a calculator to do this, but you got, yes ma'am. So, square root functions. Shifting, like absolute value equations, okay? Like some of the other things that we've done. Even when we looked a little bit at circles, we had some shifting type things that we did. Well, we're going to do the same thing now when we're doing it with radicals. So here's basically what we've got to work with. When we're doing these, okay, before, when we had these, we used our h and our k to find our vertex, and then we plotted a couple more points and drew our u, or our v, if it happened to be the absolute value equations. Now, we're going to start doing this h and k are going to be used as shifts. Now, we'll talk about those, and we're actually going to talk about them now. When you're looking at the value underneath the radical, okay, this is my left and right shift. And just like it's been in every other case we've had with the absolute value graphs and with the parabolas, it's the opposite of what you would think. If it's minus, we're going to be going right. If it's plus, that's telling me we're going to be shifting left. Okay? So there are some what's called transformations involved with this. They're just fancy words for shifts. So then, if I do have a value just sitting on the end that isn't inside my radical, those are my up and down shifts, but they do stay true. Up is plus, down is minus. So like it mentions just below, it says similarly, the graph of x, the square root of x minus 2 minus 3 is the same as the graph of y equals square root of x shifted 2 units to the right. So again, it's the opposite of kind of what I would think. And 3 units down. So if this is my regular graph, and we'll do that down here below in just a minute, I'd just take each of the points on it, and I would go 2 right and 3 down. There's my new point. Okay, or if I had a point here, 2 right and 3 down, and I can draw my line. So what I'm going to show you today is there's going to be 2 ways, one with the calculator, one without, that I can graph these. Okay. But for the moment, I want to make sure we understand what the values mean, what the shifts are. So let's see, I can keep this all on the screen here. So for this first one, I've got 2 shifts. What are they? Okay. So we're left 1. Because again, when I see the minus in my radical, oops, Harty, bad man.
And that's how we write left one.
Yeah, except it's going to be right 1 because I miswrote.
Oh.
And up 2, yes. So if you're just asked for the shift, and again, that also can use the word transformation sometimes. The book will change wording on you, okay, of each function. All right, so now that I won't do that again, what about number 2?
So, write 3 and down 2.
Write 3 and down 2. Number 3.
Left 3 and down 2.
Now we're getting somewhere. Left 4, because again, it's the opposite. You'd think plus would be going to the right, but it's not, because the formula is x minus h, or the opposite. So left 4 and down 3. And what about that last one?
Left 2 and up 1.
All right. Left 2 and up 1. Okay. So, how are we going to use that to help us out when we're graphing these? Well, here's what we're going to do. Scooch this up a bit. Okay, the equation y equals the square root of x. It's the square root function. Graph the mother graph below. Now, I'm going to use the calculator to show you something, but I'm hoping that's going to help it make a little bit of sense where we don't necessarily have to use the calculator each time. So if you're going to use the calculator and you haven't played with square roots on here before, to get the square root to show up, you're going to hit second and you're going to hit x squared, because that's going to get me the square root. And again, the fancier yours is, you may not have to close parentheses like I do, but you'll see the same idea. So I'm going to do the square root of x, so the button with xt, theta, and n here, and I'm going to close mine. So when we graph these, we got an idea of what it's going to look like, okay? Looks like half a graph. Looks like half a parabola turned sideways. And in some ways it is, but we'll get back to that. But if I look at my chart, so once I have it, I do second graph, get my table. It's always easier to graph whole numbers. So the only numbers I'm going to write in my table right now are ones that come out nice. So for instance, if I start going up here, like, wait a minute, why, if you keep going, are all those error messages there? Well, if you think back to what the graph looks like for a minute, the picture, notice it stops at 0. So let me look at my chart again here. Oh, the errors happen everything after 0. Because if I plugged in a number that's negative, like -1, in here for x, well, the square root of -1, that's undefined. It's an imaginary number. So anytime you see error, that's basically saying, okay, the graph doesn't exist over there. You got to find where the numbers start. So here, okay, 0, 0, that's a pretty easy number to work with. And 1, 1, okay, that works pretty good. And 4, 2, because I want to keep this as simple as we can. Okay, and 9, 3. So if it can fit somewhere in the graph, I'm just going to check. And there may be more, but they're not going to fit on my graph, so I'm just going to use these. So I'm going to plot these points. So 0, 0, 1, 1, 4, 2, and 9, 3. And again, my line is only going to go out from that as it continues to the right. Oh, gee, let me get it where we can, there we go. Because if I kept it going this way, I'd be saying part of my graph's here, but I know it's not. That's undefined to the left of this. So this is what my quote-unquote mother graph looks like. And when it says must memorize graph, really, it's better to remember what x values would go in. But I start to look at those x values a little bit. What do those x values have in common? What types of numbers are 0, 1, 4, and 9? Perfect squares, okay? So what I want to have happen is whatever numbers I plug in here, I want them to end up being perfect squares, because then when they come out, they're nice. So if it's just a base graph, these are the 4 points that I'm always going to use. We'll keep that in mind as we move a little bit further. But oh, we're back to domain and range, and I got to remember this. Okay, domain is my x values. Range is my y. But here's the part I've got to remember. Even if I get my x values right, I need to be able to express them correctly. So when I'm doing domain, I'm always talking about the furthest point left to the furthest point right. And when I'm doing range, I'm always doing bottom to top. The lowest y value to the greatest. So when I start to look at my graph, I'm like, okay, what's the furthest x value to the left on this graph? 0. And since I'm including that point, I'll use a bracket. What's the furthest point right? To infinity. Because it goes forever.
Wait, why'd you use a bracket for the
Because the actual value 0 is actually included on this one. If I wanted to go all the way up to 0, but 0 didn't count, that's when I use a parenthesis for that. So for all of these, when you're doing domain or range, if it's a number value, you're always going to use the bracket on these. It's always going to get included. So my range, where's my lowest value of y? 0. And again, it goes up and up and up and off to infinity forever. Now again, if we start getting shifts, that's going to change my domain and range. And that actually combines and kind of blends in with this too. So it kind of is going to all come together as we start to do these. So again, and I know we already did this up top, but it's good to reinforce it. So this is my funky mathematical way of writing out radical expressions. Okay. A is going to determine the width, okay? If it's wide, if it's skinny, or something like that. So when my value, and I'm just going to make it absolute value because negative, it's not as much of a deal, okay? If that's greater than 1, so like if it's 2 or 3 or 4 or something like that, it's going to make my graph get wider or fatter. My little curve's going to get really, really stretched. If my A is less than 1, and I'm going to have to squeeze this in. Stay with me. If it's fractional, so that's, let me just rewrite it. Let me rewrite it because I don't want any confusion here. Okay? If my A is fractional, so like it's a half or a fourth or 2/3 or something like that, that's going to make my graph skinnier. So my little curve here would get really thin. It'd almost be like it's a straight line, almost. So I'm like, okay. And then there's one other part with my A. If I have a negative A value, my graph, instead of opening upward like it does most of the time, it's going to open down here below the x-axis. It's almost like it's going to flip. It's going to be like a mirror image. So you're like, okay, that gives me a little bit of info, even though the calculator or me plugging in some numbers had helped. And then H again is going to be my left or my right shift. And again, just as a reminder, put the signs in there with. If you have to look back as you're doing something, that's okay, because hopefully as you do more of them, then you start getting the hang of it, and you wouldn't have to peek at this. And K is my up and down shift, but they do stay true to what you would think they are. Okay? These are things with the square root functions you've got to know. But they're similar in what we've done before with the absolute value one. So it's not like it's something absolutely brand new to us. Okay? But like I said I'd help you with these, both with the calculator and without. So I'm going to stay true to my word. And we're going to flip over. Okay. Now, when we graph these, okay, we're going to always figure out what the shifts are first. Then we'll talk about if we want to use the calculator or not, as far as some of the rest of them go. So what are my two shifts on number 5? Yep, left 1 and down 3. Now, this first one I'm going to show you both ways, because again, I'm going to make myself a little chart. I'm going to say, okay, now let's see if the calculator helps me or slows this down a little bit. And for some of you, it could be either. So, all right, let me get this in here. So we got the square root of x plus 1. critical that you close the parenthesis, or if you have a fancier one that takes care of that, that you right space one, that this minus 3 isn't under your, oops, minus 3, not minus plus.
How do you do the space?
You would right arrow. Because if some of you, let's see if everybody's looked the same this way. We'll do it this way than this first one. Looks like our graph has shifted from its regular left and down. So if you punch yours in and you're not getting something when you hit graph that's similar to this, tell me. Let's get that set right away, because I want the calculator to be a good thing, not be giving you wrong answers here. So get that punched in. We'll wait a second here. If anybody's having a rough time with it, we'll get you set here. Okay, let me get paused for just a calculator's turned off on me. Okay, now I want to look at the chart. So just like before, I want numbers in here that are going to be nice. So I'm kind of looking and I'm like, okay, let's see. Oh, there's the errors. I don't want those. Okay. So you're like -1, -3, 0, -2, 3, -1. And sometimes I may get a lot of numbers that'll work. Okay, an 8, 0. Now some of you are sitting there as you're writing this kind of scratching your head going, now you just said a minute ago that you want perfect squares. Last I checked, -1, 0, 3, and 8 are not perfect squares. So what's the deal? But remember, when I'm plugging them in, let's look at that for a minute. -1 plus 1 is 0, right? Okay, that was in our original list. 0 plus 1 is 1. 3, if I plug it in for x, 3 plus 1 is 4, and 8 plus 1 is 9. So yeah, they still are those perfect squares, but I have to adjust to it. When I'm plugging my numbers in, if I plug in a number for x that turns this into a perfect square, they'll come out nice. Now, couldn't I just plug it in the calculator and really not have to worry about it? Yeah, but again, that's going to come back to the number sense that some of you are lacking. If you think about it this way and you try to make yourself do this, it's going to help. But this is the thing that's going to be kind of cool. Okay, let's plot these, and then I'm going to show you how I could have done this without even messing with the calculator. Okay, so I'll get my curve in there. Again, only put the arrow to the right. Don't have it go in both directions. That won't, that's not good. Okay, let's chat about domain and range, and then I will chat about how we can uncalculate ourselves here. Where's the leftmost point of my graph, x value wise? -1, okay? That might be interesting. I may have to come back to there. Okay, what about my range? What's my lowest value? -3. Look back at your shifts. Normally, if it's our mother graph, it's 0 to infinity, 0 to infinity. I shifted left 1. My domain shifted left 1. I went down 3. My domain went down 3. There's a direct relationship with these. Anything you move left or right is going to move your domain that much. Anything you move up or down is going to move your range that much. Okay, so they go together. So even if I didn't draw the picture, I could figure that out. But you're like, so how is this going to work? You're telling me I can graph this without doing the calculator. How? Okay. You remember we did the mother graph on the front? And I said you need to know the points at 0, 0, 1, 1, 4, 2, and 9, 3. Okay, if those points would have been there originally, if we'd had the mother graph graphed on here, and then I took each of those 4 points and I did my shifts, left 1, down 3. Oh, there's one of my points. Left 1, down 3. Left 1, down 3. Left 1, down 3. I didn't even have to worry about closing the parenthesis on my calculator, right arrowing to make sure I got out from underneath the radical. If I just make my mother graph and then do the shifts that I'm told, I can do it without the calculator. Okay? Now, it's easier to do them without the calculator if there's not a number in the front that's going to mess with you, but we can even do that, to be perfectly honest. Okay? So let's play with one that does have a number in front. Okay? Now let's see what we know about number 6 before we ever punch it in the calculator. What are my shifts on number 6? Right 2, and what about the 1? Up. Now, I also know by seeing this negative 3, it's going to flip downward, and it's going to stretch. It's going to be a little bit wider because the number's bigger than 1. So I go, okay, this ain't going to be bad. So here's what I'm going to do this time. I'll plug it in again because I want to start kind of seeing the relationship. And the more I play with these, the easier it's going to be able to see what that is. So all right, so negative 3 x minus 2. Close your parenthesis, or again, right arrow to get out of there. Okay, and then the plus 1. Now again, if you want to go straight to the table on this, there's nothing wrong with that. Actually, let me undo my second. I want to see what this looks like first. Notice it opened down, and it's wider than our other one was. It's stretched out. So I'm like, okay, this is looking like it should. I'm feeling pretty good with this. So let's, okay, there's the errors starting. So again, if you're going to go to a chart, try to go again with the whole numbers. And we're going to try and reinforce ourselves again to remember how I could do this on my own. Because on number 7, we're going to. We're going to go calculatorless. I know it's a scary thought. Okay, I only got 3 points this time. I guess I could use the 11 and the negative 8. Okay, so I got my points. 2, 1. 2, 1. And 3, negative 2. And 6, negative 5. And we're a little past here, but that's okay. And again, even with just those 3 points, or 4, I've got enough information to get a pretty accurate sketch. And also, to be able to do my domain and range. Now remember, even if you weren't looking at the graph, we should be able to figure out the domain and range pretty easy, because they go directly with my shifts. So where's my domain starting? Okay. Right, I shifted right 2, so my domain shifted right 2. Goes to infinity. Range, be careful. Bottom to top.
Oh, would it be 1 plus 1?
You're close. Since it flipped and opened downward, okay, the first part of my values are all these way down here. So I have to start with negative infinity. But then as I come up, my highest point is 1. So if it's a negative, that can really kind of mess with your range a little bit. Okay. So let's see. All right. And like it says down here as we get to number 7, again, we know when you've got it available, you're going to use the calculator to see what the graphs look like. And you should, and that's fine. But it does go quicker if you don't have to rely on the calculator. So this one, okay, I'm going without a calculator this time. Oh boy. Okay, what are my 2 shifts here at the start? Okay. Left 2, down 1. Okay. It's going to open up this time, because that's positive, but it's going to stretch again. So before I ever start doing my graphing, I know it's a shocker, I need to be able to do my domain and range. If I shifted left 2, where is my domain going to start? So we'll start at negative 2. And then my range, it's opening up again, so we're going to head to positive infinity. Where's my range going to start? Negative 1. Yeah, but always remember, domain is left to right. If my graph's opening and going to the right forever, I can't say it's infinity to negative 2, because then I'd say infinity is the lesser value. And that's what I've got to be careful of. No, we're still going to graph. But But I'm just trying to let us see we can get a lot of information just from the equation when we're doing this. Now here's the part that's going to drive some of you nuts, because we're going to go number sense here. And I'm not going to the calculator at all. Here's what I need to look at. I'm just looking at this for right now. Just what's underneath the radical. Now remember, we like the numbers that turn into perfect squares. These aren't the numbers I'm plugging in. I'm just thinking about this. What could I add to 2 to get 0? -2. Okay, so my first number is going to be -2. What can I add to 2 to get 1? -1. What plus 2 gets me to 4? 2. And what plus 2 gets me to 9? 7. You're like, okay, now what are you doing again? I'm just looking at this. What numbers can I plug in for x to get my perfect squares that I want out? Because now if I plug them in, everything's going to come out nice. -2 plus 2 is 0. 3 times 0 is still 0. -1 is -1. If I move to the next one, and I'm going to show you this on the table in the calculator in a minute, just so you know you can check. -1 plus 2, because I'm just plugging in for x, is 1. Well, the square root of 1 is 1. So 3 times 1 is 3. -1 is 2. And again, even if you want to plug this in on a regular calculator, you could. 2 plus 2, my x, so it'd be 4. Square root of 4 is 2. 2 times 3 is 6. -1 is 5. And finally, 7 plus 2 is 9. The square root of 9 is 3. 3 times 3 is 9, -1 is 8. Now let's see if the calculator agrees with us. And if we have a calculator in our brains, which we do, we just don't use it sometimes. So I'm still going to go ahead, I'm going to type this in just like we've been doing on the other ones. But we're going to prove to ourselves that we don't need no stinking calculator. All right, let's see if these worked out here. X is -2, y is -1. Absolutely. X is -1, y is 2. Absolutely. 2, 5. Absolutely. 7, 8. Woo! Okay. So now I can plot my points. 2, -1. -1, 2. Make sure when you, on your chart or when you did it on your own. Okay, that is probably going to be, and we will take a peek here, that is probably going to be an issue with a button somewhere. I'm going to sound like I'm in a cage now. I'm running away from it. Yeah. For the minus one out here, I've got to use this place, not the negative, since they're moment. Yeah, because it just got longer when I did it. So yeah, and I think now if you go back to it, you should be good. So now, here's what I kind of want us to do, because what happens for the rest of the note packet, and we'll talk through a couple more of these tomorrow if we need to, but I'm also going to have this in on full online later. It's just talking about some of the different shifts. We'll talk about the cubed root part tomorrow. So here's what I want you to do. Let me move this up a little bit. So for the problems that are here, okay, you can get a start with the square root ones. And like I said, we will take a look at the cubed root ones tomorrow. The square root ones that would work out okay, well, you could still do the descriptors, so those are all okay. 26 is okay, 28's okay, oh, 29's okay. I am a happy camper. Okay, so everything through here is okay right now, because you're just describing shifts on these. That doesn't change at all for any of them. And then these three are graphing square roots. And we'll take a look at the cubed root ones tomorrow. Okay, and we'll get those finished up, and then maybe even we'll just do like a worksheet of sorts just to kind of make sure that's going okay, and we'll save the other part for Wednesday. We'll see how that goes. But do try out, even if it's just one, okay? Try one of them out before you walk in tomorrow.